All right, let's try this example here. Suppose the mean GPA of a high school is 2.4 and the standard deviation is 0.2. Assume the distribution is not normal. By the way, that wouldn't be a problem because Chebyshev's inequality applies to any distribution. So the fact that it's not normal doesn't matter. What is the minimum percent of GPAs between 2.0 and 2.8? Okay, so recall the formula for Chebyshev's inequality. It looks like this. We need to know this k value here, and k is the number of standard deviations away from the mean. So in this question, we don't have that, so we have to figure out what it is. So I'm going to do it a little bit differently than I did in the video. What I'm going to do is I'm going to start with the mean here. The mean is 2.4. If I add 1 standard deviation to that, then I would get 2.6. Okay, so this is the mean plus 1 standard deviation. So I haven't gotten to 2.8 yet, so I'm going to do it again. So I'll take the 2.6 and I'll add the standard deviation again, and I get 2.8. So this is the mean plus 2 times the standard deviation. So this is the value that was given in the problem. I had to add 2 standard deviations to get that. So this is making me think that my k value is 2. In order for this to work, this also, the 2.0, needs to also be 2 standard deviations away from the mean. Because remember that k is within k standard deviations of the mean, meaning above and below. So if I take the mean and I subtract 0.2, I get 2.2. That is the mean minus 1 standard deviation. So not quite there yet. Let's take the 2.2 and subtract another standard deviation. That gives me 2.0. So that is the mean minus 2 standard deviations. So this is looking good. This is 2.8 is the mean plus 2 standard deviations. 2.0 is the mean minus 2 standard deviations. So the k value I should be using is 2. So what this question is actually asking is, what is the minimum percent of GPAs within 2 standard deviations of the mean, which is asked in a slightly different way. So to answer the question, we plug this k value into the formula for Chebyshev's inequality. It's 1 minus 1 over 2 squared times 100%, which I'm just doing this in my head. I believe it's going to be 75%. So in the video, you noticed I used this formula, mu plus k sigma, and that's sort of what I'm indicating here, but this is just a slightly different way of looking at it, where you don't actually have to solve using the formula. So I really hope this helps for you to understand the second part of the example from the notes.